This
Good
conference
morning,
will
students.
now be recorded.
Can you hear my voice? వాయిస్ వినిపిస్తుందా? Students, can you hear my voice?
Audible, sir.
All right. Okay, good morning, students. Today we are going to discuss about field test and retardation test. Right? Yet till now we discussed two methods of testing methods. One is direct test and indirect test, right? So what is the example for direct test? What is the example for direct test?
Brake test, sir.
Right. So in this test we are applying the load directly on the motor, right? So in this method we are going to find that efficiency and what is the output and what is the torque. By using these parameters we categorize the performance of a DC motor. Generally the brake test with is preferable only DC shunt motor, so we can't able to apply this type of test on DC series motor. Why? Because that for applying the load for DC series motor it needs more load. Why? Because the DC series motor should be running at high dangerous speed. So if you want to apply the load it should be high because it has to be more load. So that's why we are going to use that indirect test. So in indirect test we have different types of test. One is Swimman test, second one is retardation test, Hopkinson test and field test. So already we finished that Swimman test and Hopkinson test. What is the use of Swimman test?
Efficiency for motor and generator, sir.
Right. Right. When DC machine running as a motor, how it will give the efficiency? The same machine when we are working as a generator, how will give them efficiency? So to determine that a DC machine, how it will be working and how it will be give performance when it is running as a motor and when it is running as a generator. So this is happened by using the Swimmer test. But this Swimmer test we can use only on DC shunt motor at the same time at no load condition. So here we are not applying any load on the DC motor. So that's why the Swimmer test is also known as no load test. So here we just assuming that what is the load at what load how it will give the efficiency, right? Like a 1/4 load, half load and so these are the no load test. Next thing is Hopkinson test. So Hopkinson test is already over, right? So what is the purpose of Hopkinson test? Why we are using the Hopkinson test here? And tell me how it will be conducting. Hopkinson test ఎలా యూజ్ చేస్తారండి? Can you see the document here? Testing on DC machines. Students, can you see this document on the under the display?
Yes, sir.
Right. So if you see this document here, the testing of DC machine is classified into two types. One is direct and indirect method. The direct method, so we are using that how we can give that load, how we can calculate the efficiency. So that thing we are going to use the direct method test. Now we are going to discuss in today's class the remaining two topics. One is field test and another one is retard test. So this is the circuit diagram here. The circuit diagram is used for that Hopkinson test. So what is the purpose of Hopkinson test means? If you see this diagram here, wait. See, if you see this diagram here, this is Hopkinson circuit diagram. Here we are using that 4 ammeters and 1 voltmeter. And 4 ammeters, what is the purpose of 4 ammeter means? 2 ammeters is used for one machine and another 2 meters you are using for another machine. So it is a combination of motor and generator set. Why? Because we are giving the electrical energy to the motor and it is coupled to the generator, and finally you are getting that electricity as an output. Now, what is the main intention of Hopkinson test means? When we running as a motor generator set, how many losses, what are the losses will be happening in that combination, right? Suppose if you are giving that 100 volts to the motor, that is electrical energy as input. Now, the motor will be give mechanical energy based on the supply voltage, that is 100 volts, and the same mechanical energy is supplied to the generator, right? So now what will give the generator? Electrical energy. So the same electrical energy is used for again input to the motor, but it never happened. Why? Because when compared to the motor and generator have the more efficiency, and there are certain losses will be happening. So due to the losses, we won't get that electrical energy what we giving that input energy. అంటే మనం మోటార్ కి ఎంతైతే ఇన్పుట్ ఇస్తున్నామో జనరేటర్ నుంచి సేమ్ అవుట్పుట్ అనేది తెచ్చుకోలేము because certain losses. Now in this Hopkinson test, how we can maintain that equal representation means by using the voltmeter. So can you see this voltmeter? It is connected across the switch, right? So when it will happen means when the voltmeter shows that voltage equals to 0. So that is when it is the voltmeter shows the 0 reading, then we can easily clarify that motor and generator both are running in same path, right? So same path in the sense whatever electrical energy is giving to the motor, and based on that it will convert to the mechanical energy, and this mechanical energy is applied to the generator, and the same electrical energy is coming from that generator. So when it will to one input and output is both are same, at that condition the voltmeter shows the 0. So when it is shows the 0, then it shows that both running as a same efficiency. So this is the verification of Hopkinson test. So Hopkinson test, what is the purpose of Hopkinson test means? We need to find that what is the input and what is the output. So in between, what are the losses will be happening. If the losses is happening, what we have to proceed. అంటే లాసెస్ జరిగితే మనం ఎలా దాన్ని రెక్టిఫై చేయొచ్చు. సో దట్ ఈస్ ద థింగ్ హ్యాపెనింగ్ హియర్. Now if you observe this the formulas which are using for Hopkinson test, here the V is the supply voltage and motor input power, that is V into I1 plus I2. Why? Because here I2 it is flowing in the motoring circuit and I1 is flowing in the generator circuit. So then the two I1 and I2 both are entering current to the motor. That's why we are getting that the motor input power is V into I1 plus I2 and generator output is VI1. Our intention is the motor input is equal to generator output. So if it is possible, then Hopkinson test is verified. So ఇక్కడ proof ఏంటంటే motor input to generator output రెండు సేమ్ ఉండాలి. So if the both are same, then the process will be verified. Now if it is happen, now what we have to find means we had to find that what is the efficiency. See, if the both machines having that same input and same output means it having that both same efficiency, right? So if there is any drawback, then efficiency will be less. But here we are assuming that motor input is equals to that generator output. So ఇక్కడ ఎలక్ట్రికల్ పాయింట్ ఆఫ్ వ్యూ ఇన్పుట్ సేమ్ ఉంటుంది, అవుట్పుట్ సేమ్ ఉంటుంది. దెన్ When both our parameters are same, then efficiency also same. So now just we are assuming that both machines having that same efficiency. Then what is the efficiency formula here? What is the efficiency formula? Students, what is the efficiency of efficiency formula?
Output by input, sir.
Right. Output by input. Now, if you see this equation, that is a diagram here, the sentence here, uh, output of motor is equals to efficiency into input. Why? Because we are calculating that motor, right? So motor, we need to find that we need to use that electrical energy. So here, for motor, the electrical energy is a input, right? Now we'll see this. Right. Now, if you see this sentence, the output of motor is equals to efficiency into input. So here output of motor is mechanical energy, right? So mechanical energy is equals to efficiency into electrical energy. Now, the same input we are getting from that generator, right? So efficiency is equals to, what is the motor input formula here? V into I1 plus I2. Now, the output of motor is nothing but a input to the generator. Why? Because the output of motor is mechanical energy, right? The same energy we are applying that input to the generator. Now, output of generator is equals to efficiency into input. So here input of generator, what it is? Efficiency into V I1 plus I2. So finally you will get that the efficiency formula is equal to square root of I1 divided by I1 plus I2. So this is the formula we need to find in the Hopkinson test. Now these are parameters are certain used to find that losses, that is armature copper losses, field copper losses in the motor as well as generator. And finally we conclude that Hopkinson test is suitable to find how the motor and generator both are combinedly working. So combinedly working in the sense they have to be work coordination. So coordination meaning ఏంటంటే రెండు ఒకేలాగా వర్క్ అవ్వాలి. Process. So it means now so what is the other name of Hopkinson test?
Back to back test or regenerative test.
Right. Why it is called as regenerative set? ఎందుకు దాన్ని రీజనరేటివ్ టెస్ట్ అంటారు? Why we called as regenerative set? Because regenerative అంటే మనం ఏదైతే అవుట్పుట్ నుంచి వస్తుందో తిరిగి దాన్ని ఇన్పుట్ గా యూజ్ చేసేదాన్ని రీజనరేటివ్ అంటారు. సపోజ్ ఇప్పుడు సోలార్ ఎనర్జీ ఉంది అనుకోండి, సోలార్ ఎనర్జీ ఇస్ రీజనరేటివ్ అంటే ఇట్స్ నాట్ ఎగ్జిస్టబుల్, అంటే అది అయిపోదు, తిరిగి మనం అవైలబుల్ గా ఉంటేనే ఉంటుంది. సో దట్స్ వై వెన్ the input and output process both are combined in cyclic process, then we called as a regenerative test. So this is the second test for direct indirect method of testing. Now we are going to discuss the third method is field test. Generally the field test is not useful for real time applications. Why? Because this test is suitable for series motors. సో దిస్ విల్ బి యూజ్ టు అనాలిసిస్ అంటే ఏంటంటే ఒక సాఫ్ట్వేర్ యూజ్ చేసుకొని అందులో వీ నీడ్ టు ఫైండ్ దట్ సర్క్యూట్ డయాగ్రామ్. సో సర్క్యూట్ డయాగ్రామ్ డిజైన్ చేసి ఈ సిరీస్ మోటార్ కి ఎంత లోడ్ అప్లై చేయొచ్చు, ఇఫ్ ద లోడ్ ఈస్ అప్లైడ్ వాట్ ఈస్ ద స్పీడ్ ఆఫ్ దిస్ సిరీస్ మోటార్, సో ఆ విధంగా అనలైజ్ చేయొచ్చు అన్నమాట. సో ఈ సిరీస్ మోటార్ అనేది వీఆర్ నాట్ యూజింగ్ ఇన్ దట్ రియల్ టైమ్ అప్లికేషన్స్, వీ కెన్ యూజ్ ఓన్లీ ఇన్ practical, that is laboratories. Now this is the circuit diagram for field test for series motor. So here the name itself indicates that field test, right? So we are testing on by using the field wedding. By using the field wedding, we are going to be test on this method. Now if you observe the diagram here, the motor and generator set. So we are considering the motor and generator set. Here motor is acting as a prime mover and generator is acting as a load. Now so this test is connecting on DC series motor, right? So when it is called as DC series motor, when we call DC series motor,
Field winding is connected to series, no?
right? When field winding is connected in series with armature winding, then we call as DC series motor. Now if you observe this diagram here, the field winding is connected in series with armature winding of motor, and one end of the armature winding of motor is connected series with field winding of generator. సో ఇక్కడ మీరు అబ్జర్వ్ చేస్తే మోటార్ యొక్క ఫీల్డ్ వైండింగ్, జనరేటర్ యొక్క ఫీల్డ్ వైండింగ్ రెండు సిరీస్ లో కనెక్ట్ అయ్యాయి, right? In between armature winding. See here. From first thing is this is the field winding, and see here, this is the field winding, and it is connected with armature winding as a series, and one end of the winding is connected to the field winding of generator. So that's why the entire process is based on that field winding. That's why we are calling it as a field test. Now this test is applicable to two similar series motor. Here we are considering the two similar motors. One is acting as a motor, another one is acting as a generator. సో ఇక్కడ మీరు అబ్జర్వ్ చేస్తే ఎక్కడన్నా రెండు డివైస్ కనుక కంబైన్డ్ గా వర్క్ చేయాలంటే దే హ్యావ్ టు బి ఈక్వలెంట్ పారామీటర్స్. అంటే ఈక్వలెంట్ పారామీటర్స్ అంటే సేమ్ వోల్టేజ్ ఉండాలి, సేమ్ స్పీడ్, సేమ్ కరెంట్, సేమ్ అవుట్పుట్ పవర్. సో ఇఫ్ the two devices having the same ratings, then only we can consider the test. Otherwise we can't able to conduct the test here, right? Now in these two series motors, one of the machine run as a motor and another one is run as a generator, and output is wasted in a variable load R. So ఇక్కడ మనం అవుట్పుట్ అనేది ఒక రెసిస్టివ్ లోడ్ కి ఇస్తున్నాం, right? Now the both machines field coils are in series and both run at a same speed. Why? Because when the field winding are connected in series, then it is we can easily say that the two resistors are additive in nature. When the two resistors are additive in nature, then the two machines having that same speed, so that iron and friction losses are made equal. So iron losses, friction losses అనేవి రెండు కాన్స్టెంట్ లాసెస్ అన్నమాట. సో ఎప్పుడైతే రెండు సేమ్ స్పీడ్ లో రొటేట్ అవుతాయో, then these two losses are same. Now let me see that what are the parameters we can discuss here. The first thing is here the load we are considering as a R, and one more thing, R is varied till the motor current reaches to full load curve. Right? And V is a supply voltage. If you observe this diagram here, we have the two ammeters and three voltmeters, V1 and V2. So what is the value indicated by the V1? V1 దేని ఇండికేట్ చేస్తుంది? What is the indication of V1?
Motor voltage.
Right. So motor voltage, so motor in back EMF. Okay, now why? Because it is connected across that series winding and armature winding, right? So in armature winding, the availability of EMF is back EMF. So here the voltmeter 1 measures that what is the back EMF is available on that motor armature winding. At the same time, we are connected, V2 is across the armature windings. That's why the V2 measures that what is the generated voltage available in the armature winding. And here we have the two ammeters, I1 and I2. So here I1 is a series current. So here in this case, IS is equals to IL equals to IA. Why? Because in series motor, three currents are equal. Now we can simply say that I1 is a motor current and I2 is a generator current. So generator current in the sense it is a load current. Now input to the motor generator set is input power, that is V into I1, and output is V2 into I2. So this is the input and output power. So input, it is electrical energy to the motor, and output, it is electrical energy from the generator. Now RA and RSC are hot resistances. So why it is called as hot resistance means, generally the resistance of armature winding and series winding having that low value, right? When the resistance is low, then there is allowing of more current. Due to this flow of more current, the resistance will be heated up. That's why the armature resistance and series resistance we are simply called as hot resistances. Now the total losses in the set is Vt is equals to Vi1 minus V2I2. So here generally the total losses in the sense we have to be add, right? WC plus WCU, right? So here why we are using that minus means, here the current I1 and I2 both are flowing in the opposite direction, right? So opposite direction sense, if you see the motor, the current is coming from supply to the armature, but in the case of generator, the current is coming from armature to load. So that's why the current directions of motor and generator both are in opposite direction. That's why I'm using minus sign here. That is the total loss in the set, that is Wt is equals to Vi1 minus V2I2. So if you subtract these two values, then we can easily identify that how much of losses. So why? Because Vi1 is a input and V2I2 is a output. So when input minus output, then we can get what is the availability of losses happening in this test. And the next one is armature and field copper losses. We can write the equation like this: WC is equals to RA plus 2RSC. 2RSC in the sense, here we have the resistance of field winding, right? RSC. So one is RSC, another one is motor and generator. So that's why we got that RS2 RSC. I1 square plus IA square RA. Now this is the total copper losses which is related to armature and field. So finally we will get that stray losses, and we will get total losses minus copper losses, we will get stray losses. So what is the main intention of this type of field test means, we need to find the efficiency. General ga manaku series motor of an efficiency find out cheyalante, it is not possible to without load. Ante load lekunda mana efficiency ni find out cheyalem. It is highly impossible. Why? Because the speed should be high dangerous speed. Now, but practical purpose in laboratories, we can conduct this efficiency finding test by using this combination, that is motor generator test. Now in this test, we got that values, the stray losses for Wt minus Wso. So this is the stray losses for both combination, that is combination of motor and generator. Now we need to find that individual losses. So individual losses means we have to be divided by 2. So divide by 2 చేస్తే మనకు మోటార్ కి జనరేటర్ కి సెపరేట్ గా వస్తుంది. సో Ws is equals to Wt minus Wc divided by 2. So this is the losses obtained individual mission. One is for motor, another one is for generator. Now the losses we can write Ra plus Rsc I1 square plus Ws. So this is the losses of motor. So finally the efficiency of motor is equals to, so how we can write the efficiency of motor? in terms of electrical energy? How you can write that efficiency of the motor?
Input minus losses by input, sir.
Input minus losses, right? So here you can see this. The input power is V into I1, right? And losses, the losses we are applying like armature field copper losses and stay losses and divide by input. So finally we will get that efficiency of the motor. Now we are going to find that efficiency of the generator. So efficiency of the generator, how we can write efficiency of generator in terms of electrical parameters?
Output by output plus losses, sir.
That's output divided by output plus losses. So this is the way we need to find that field test on DC series motor. Just simply remember this diagram here. So how we can write means, first this field test should be conducting on two similar DC series motor. That is the first point. Next point is, in the two series motor, one is using as a motor, another one is using as a generator. So that is the second thing. And while conducting this test, the two devices having that similar parameters, and these two devices should be rotating in the same speed. So this is the 3 points you need to write at initial condition. Now just draw the diagram here. Now from the diagram we can easily say that the field winding of the motor, that is series field winding of the motor, it is connected in series with field winding of the generator. Now that's why the entire test should be based on that, how the field winding are connected of motor and generator. So motor and generator sense, the field winding of the motor is connected in series with field winding of the generator. That's why this test is called as field test method. Now here we are using that three voltmeters. The three voltmeters are, one is to measure that what is the input voltage we are applying the motor. That is the first voltmeter, we are indicated by V. And second voltmeter, that is V1, it is connected across that series field winding and armature winding, and it gives that voltage, that is a back EMF available on the armature winding of a motor. Next, third voltmeter, that is V2. So V2 measures that what is the EMF generated across the generated armature terminals. Now we have the three voltage ratings. One is supply voltage, back EMF, and generator EMF. And we are using additionally two ammeters, I1 and I2. So here I1, that is current, it is flowing through the motor, and I2, the current which is coming from the motor generator. సో ఇక్కడ I1 అనేది ఇన్పుట్ కరెంట్ తో బేస్ చేసుకుంటుంది, I2 అనేది అవుట్పుట్ కరెంట్ బేస్ చేసుకుంటుంది. By using these 5 parameters, we need to find that what is the input power of the motor and what is the output power of the generator. So when both input and output are same, then it should be working in the same speed and same parameters. By using these parameters, we need to find the efficiency. For motor efficiency, we can write in terms of electrical energy, input minus losses divided by input into 100. So here input is a power. Input power is V into I1 minus losses. So here losses we have armature copper losses, field copper losses, and stray losses. Why we are considering armature and field means both are having that low resistance value. That's why there is availability of copper losses. Now finally we will get efficiency of the motor is equals to V into I1 minus total losses divided by V into I1 into 100. This is the efficiency of a motor. Now if in the case of generator, we can write generator efficiency is output divided by output plus losses. Why? Because we need to represent that EMF equation always in terms of electrical energy. So that's why the electrical form of generator is output, right? So output divided by output plus losses into 100. See here, what is the output of the generator?
Electrical energy, sir.
Right. So electrical energy divided by electrical energy plus losses. So now we obtain that all entire equation in terms of electrical formation. Now in this circuit diagram, the output of the generator is I2 into V2, right? Now how we can write means I2, the efficiency of the generator is V into I2 divided by I2 V2 plus losses, total losses. So this is about field test on DC series motor. Now we will see that retardation test. So retardation test, we call it as a running down test. So just I am saying, I will give the introduction and remaining topic we discussed in tomorrow class, right? So retardation test is used to when the device should be suddenly running as a motor and suddenly running as generator. అంటే ఒకే డివైస్ ఉంటుంది, మనకి ఎలా కావాలంటే అది మోటార్ గా రన్ చేయాలంటే రన్ చేసుకోవచ్చు, లేదా జనరేటర్ కావాలంటే జనరేట్. సో దట్స్ వై దీన్ని రిటార్డేషన్ టెస్ట్ అంటారు. అంటే ఉన్నటువంటి మోటార్ గాను తర్వాత జనరేటర్ గాను యూజ్ చేయొచ్చు. ఓకేనా? సో ఈ టెస్ట్ గురించి మీకు రేపు క్లాస్ లో చెప్తాను. ఓకేనా? రైట్. సో ఓకే స్టూడెంట్స్, దిస్ ఈస్ అబౌట్ టుడేస్ క్లాస్ and that is the field test on DC series motor. Already the same experiment ఈ experiment మీకు ల్యాబ్ లో ఉంది, DCMT ల్యాబ్ ఫస్ట్. ఓకేనా? సో this is the most important question for your semester exam, field test on DC series motor. Okay, right? So okay students, this is about today's class. We'll discuss in tomorrow class. Thank you. So I'm going to end this class now.